Hello guys, welcome back. Today we are going to be solving questions of map. In C++ STL we will be practicing maps, so I will be starting from the first problem. If the first couple of problems are a bit too easy, I won't be explaining them either. So let us start with the first one. You can also try it out with me if you want to. I will mute myself now. Also, the first question is done. In this, we just had to get a frequency count of all the elements in the vector. So you can just normally create a map. In this case, I created an unordered map for of constant time uh, insertion in the map. We would have also used a normal map. It would have kept everything in sorted order, but it would have used a binary tree internally, so the time complexity would have been low again. Anyways, that doesn't matter much. After putting it in, I just do map of vector I plus plus. So basically, if it is empty or if it doesn't have that element yet, it will be putting it in with a value of 0. And since we are doing plus plus, it will increase it by 1. That is the way this would work. And if it is already there, then it will increase it by 1. Now you can just move on to the next question. This question was nothing. Now we can just move on to the next one. You can also try it out with me if you want to. I will mute myself now. Okay, so I've solved the second one as well. In this, we had to do the same thing as the previous one. Instead of a vector, we had to do it with a string, with all of the characters in the string. So it also told us to ignore the case sensitivity in this. I didn't note, but that doesn't matter anyways. So I just create an unordered map, and I just take each character of the string and put it in the map as lower. You did not need to do this as lower thing, as you could have ignored case sensitivity, but anyways, I did it anyways. So one thing to note if you don't know this, to lower expects an integer value, so it works on a character, not a string. So if you are using that, be careful of that now. And then you can just print out the output like this. So this was it for this question. Now we can move on to the next one. You can also try it out with me if you want to. Okay, so I've solved the third question as well. In this, we had to check for an anagram. So an anagram is basically you take any word, you can take any word in the dictionary, take all of the characters of that word and rearrange them to create a new word, and these two words will be anagrams of each other. So basically both have the same characters with the same frequency. That is what an anagram is. You can also check it online if you want to. Now in this problem, what I did is I took input of two strings. I created two separate maps for these, and in the first map I kept the frequency count of characters of the first string. In the second one, I kept the frequency count of characters of the second string, and then I just checked if they're equal or not. With maps, you can just directly check if they're equal or not like this using the double equals to operator. And if they are equal, then you can just print true, otherwise you can print false. In this question, I was making a lot of mistakes. The first and the biggest one was that when taking the input, I was taking the input in the first string accidentally instead of the second one. And then again in the map, I was taking a frequency count of the first string accidentally in the second map. So be careful of these small errors when you're solving the questions yourself. Now I will just move on to the next one. You can also try it out with me if you want to. That's it. Get them there. Ciao. Okay, so next question was also extremely simple. In this, we just had to count the number of unique elements in a vector. So you can just directly create a map, put all of the elements in the map somehow, any way you want to put it in the map, and then just take the count of the map. Make sure that the key of the map is the element themselves. So only that with the map will be keeping a unique count, unless you use a multi-map, that is, or So, in my opinion, you don't need to use a map at all. You can just use a set for this. Just take all of the elements of the vector, put them in the set, and just take a count for the size of the set. In this case, since we are practicing map, I just use a map. But anyways, now we can move on to the next question. You can also try it out with me if you want to. Okay, so we have solved the fifth question as well. In fifth, we had to find the first known repeating character. Since it is the first known repeating character in a string and on map, just a normal map, it stores the elements in lexicographically sorted order. So you can just use a normal map for this. Wait a second, I don't think this would work because since it is storing elements in lexicographically,
Right.
what do you call it, lexicographically sorted order, it won't work. Let me just modify my solution a little bit and then come back to you. Okay, so now this should work completely fine. Initially what I was doing, I was just iterating the map and checking the first character. Now since map stores everything in lexicographically sorted order, if the string does not have the characters in sorted order, so that would not work. It would give the element in the map which is appearing first according to the lexicographical order. So note the first non-repeating character in the string. So what I did for this is after storing all the elements in the map with a frequency count, I just iterated the characters in the string, and then I just checked with each character if it is present in the map and if the frequency of that character is 1 or not. If it is 1, then you can just return the character, otherwise you can just return -1. Since I can return -1, since the return type is char, I can just return \0, and if it is \0, I can just print -1. I don't know if this is the best solution. Let me ask ChatGPT if this solution is good enough or not for the fifth problem. Just a second.
What? I did. We didn't.
Let's go.
Okay, so the solution is already efficient enough. Other thing that can be done in this case is you can use a queue. and store the non-repeating character in front of the queue. Basically, the first non-repeating character that you can find, you can just keep it in front of the queue and solve it like that. So that should also work. If you want to do it this way. Other than that, we can just move on to the next question. You can also try it out with me if you want to. Okay, so I have solved the sixth problem as well. In this, we were given an array of strings, and we had to group words with same frequency together. So same characters and the same frequency of those words. Basically, the words that are anagram of each other, we had to group them together. So the simplest way to solve this question is to create a key in the map. Create a key of vector of size 26, so that you can keep a track of frequency of each character and each character itself as well. So that way, using that vector as a key, you can group these elements together. So what I did for this is I created a map. In this case, I'm using a normal map because an unordered map requires a custom hash function. So for that, I will have to create a custom hashing. So I'm just using a map. This will work directly. So the key of this is going to be a vector of integers, and the string is going, the value is going to be a vector of strings. So I'm going to be iterating the input vector, and for each string, I'm going to be creating its key of size 26. Sorry, my mistake. Of size 26, and then for each of the elements, I am going to increase it by 1 for each character in the vector, and then I'm just going to push this string to the back of this key in the map. So then I can just print the output out like this, and this works completely fine this way. You can also try using a custom hashing as well. Let me try to show you that as well.
Little. Here we go. Clean. But
Okay, so as we saw, it works with the custom hashing. You have to do nothing, just create a structure, name it custom hash or anything you want. And inside of it, we are going to be calling a function called operator. Its return type is of size underscore t, and in it you have to pass the vector as a constant, or for the custom key, whatever you are using for the key.
what?
And then the return type is going to be constant as well. So in it, I just created a hash equals 0, and I just iterated the vector. Then for each element in the vector, I just took a XOR with the hash times a random number plus the element itself plus hash plus whatever the hell you might want to do with this. You can do that and just return this hash, and this should work completely fine. As I can see, this works fine. So now we can move on to the next question. You can also try it out with me if you want to. I will mute myself now. Okay, so the next problem was extremely simple. In it, we just had to find the element with the highest frequency. So for that, what you can do is you can just create a map, and you can create a variable that will be keeping the track of the mux of the element with the maximum frequency. Or you don't have to do that at all. You can also just add all the elements in the map and update their frequency, and at the end just iterate the map to find the maximum element. Although in this case I've created a variable anyway. So what I do, I just this element is initialized with the first element of the vector itself, and then I iterate the vector for each element. I update its frequency in the map, and if the frequency is greater than the frequency of the current element, then the current element becomes I, or the maximum element, I should say. If the frequency of the current element is greater than the maximum element, then the maximum element becomes I, and then we can just print out the maximum element. Very simple question, very simple solution. Now we can just move on to the next one. You can also try it out with me if you want to. I will mute myself now. Okay guys, so I have solved problem 8 as well. It might have got cut for you guys. A mistake on my part, but I've solved it. In this problem, we had to basically find the intersection of two arrays, basically all the elements that appear in both arrays, including the duplicate. So we had to do the intersection of these two arrays using a map, or using maps. So what I did for this is that after taking the input of both the vectors, I created two separate maps for both the vectors, and in it I kept a frequency count of all the elements for both the vectors. I did that for both the maps. Then I iterated one of these maps, the first one. Then I checked if the key that I currently have from this map is available in the second map or not. If it is not available in the second map, then it means that element is not in the other map, so there is no intersection between those two. But if it is found, if that key is found in the other map, then what we can do is we can take the minimum of the value of both of these keys in both of the maps, because basically that value is a frequency count, and whatever is the minimum frequency count is going to be the number of duplicate elements. So for example, let me show you. For example, in this case we have 1 2 2 3 and 2 2 4. So there are only two 2's in both the arrays, so the intersection is going to be 2 and 2. But what if instead of this 3 over here we had 2? So if it would have been 1 2 2 2, so 1 and 3 2's, and then the other one would have been 2 2 and 4. But the answer would have still been 2 and 2, because there are only two duplicate 2's in both the arrays, so the third one would not be counted. So whatever is the minimum frequency count, for example, in this case it would have been 3 if there were 3 2's, and in this case it would have been 2 2's. So whatever is the minimum frequency count is going to be the number of duplicate elements. So you take that minimum count and then you push the key or the element inside the result that number of times, and then you can just print the result out. I don't think this might be the most efficient solution, but we will see. Let us ask ChatGPT if this is or not.
Let us. Think about people. Right.
So basically, what it is telling me is instead of using two arrays, two maps, what we can do is we can just use one map, update the values of one vector in it, then iterate the other vector and update the map accordingly. So that is the solution that it is giving us. We can do that as well. If you want, you can try that out yourself. For now, I will move on to the next question. You can also try it out with me if you want to. Okay, so I have solved problem 9. I will be completely honest, I was not able to solve this myself. I had to ask ChatGPT for a solution, but anyways, the one that I have currently, I was not able to think up of that solution, but I will try to explain it to you to the best of my capabilities. So, first thing to notice is the basic condition that we have for solving this question that we are supposed to know is that whenever you are doing prefix sum, so you are continuously adding elements one by one, and each index you will be checking. So you will be checking for two possible conditions. First is if the sum is itself 0, then in that case, since the 0th index till this index, we have a 0th subarray, you can say, right? And other than that, whenever we get the same sum twice, so for example, let me show you. As whenever we get the same sum twice, for example, minus 1 would give us a 0 and 2 minus 2 would also give us a 0, right? Or you can say if we have something in the array like we have a 4 and later on we have a 2 and a 2, and the sum of this 2 and 2 is also 4, and since we are doing prefix sum, so if the sum of this 2 plus 2 becomes 4 by then the elements between the previous 4 and the current 4, the elements between these two are, their total sum is definitely going to be 0, right? So that would be a 0 subarray in itself. So you can find this out. For example, you can just take this one as well. So you have 1 minus 1, which will come out to be 0. Then you have 2 minus 2, which will come out to be 0. So this minus 2 is going to be 0, and this from this one, right, this is going to be a whole subarray. So since the sum of elements between these two, it has to be 0 as well, because the total of this is going to be same. The sum of these is going to be the same. So for this, we can count it as one subarray. So what I do for this problem is I obviously keep a count. This is the count of the subarrays, and I keep a prefix sum starting with 0 obviously. Then in the map I am already adding a 0 or 1, and this 0 is a sum. So in the map we are storing the sum. So the key is going to be the prefix sum itself, all the possible prefix sums that we can have, and the value is going to be how many times that sum has appeared, right? So we initialize it with mp0 equals 1. So the 0th sum has appeared once, which is going to be obviously if there is nothing in the array, then the sum is going to be 0. So the 0th sum is 1 and count is 0, prefix sum is 0. So for each element we are going to be adding into the prefix sum, and then we are going to be checking if it is present in the map or not. If that sum, or you can say that key, is already present in the map, that means we have added that sum once before, or not once before, as many times before as the value of that sum in the map. So we are going to be adding that value in the count. Why we are adding that value in the count? Because the current index can make a subarrays with all of these previous indexes that have the same sum, right? So the current sum, or the index with the current sum, if it is same as previous sums, or if that sum has appeared n number of times previously, then it can make n subarrays with n subarrays in the vector that have a sum of 0, right? that index specifically. So that sum with n, basically the sum appearing n times before has been stored in MP of previous index, and we can just directly add it to the count because we will be able to make that many more subarrays now, and then MP of previous sum is going to be updated with plus plus. So since we have found that sum again, we are going to be adding 1 to its value, and then in the end we can just print this count out. I will be honest, I would have never been able to think of a solution to this myself properly. I think I'm not just that smart enough, but now that we know how to solve it, we should be able to apply it in future question if needed. Also, I was thinking of storing the subarrays. That was my bad. In the output, we don't need the subarrays, we just need the count, so that makes our life 10 times easier, I would say. So always understand what the problem is asking correctly so that you don't have to go through something like this as well. What I went through, I took a long time trying to answer this question, and these type of questions can also demotivate you because you are not able to think of a solution for these. So very, very good question in my opinion. These are the type of challenging questions that I need, not a type that I am able to solve easily. And I will be honest, I never thought in this question that I would have just stored the prefix sum inside of it. I was only thinking about storing the indexes of the elements. So you can say kind of an out of the box thinking on this one, which was needed, and that worked completely fine. You can also try it out if you want to. I hope you were able to understand it correctly. If you were not able to understand it, you can check out someone else's solution. For now, I am just going to move on to the next question. You can also try it out with me if you want to. I will mute myself now. Okay, so I have solved the 10th problem as well. This problem was difficult to understand because ChatGPT was not able to explain it correctly at all. I had to search quite a lot and I had to ask it multiple times to give me clear explanation of the solution. So what we have to do in this question, I will explain it to you clearly, is we are given two arrays, like these two arrays, and we have to find if these two arrays can be made equal by doing one swap inside one of the arrays. So what it kept telling me again and again is that we had to swap between the arrays. That did not make any sense to me at all, and none of the test cases were making any sense to me at all as well. So I had to search quite a bit, and the only way that this can be done is if in one of the arrays you are swapping elements once or making one swap. Otherwise it would be a no. So after understanding the problem, I had to solve it using maps. Now this problem can easily be solved without using maps in my opinion, but okay, since we had to solve it using maps, I applied maps. What I did is, let us take the example of these two arrays. In my code, I have this function solution in which I am passing both the vectors that I've created. So first of all, I check if the size of these two vectors is equal or not, because if it is not equal, then they can never be equalized anyways. So if they are not equal, I just return false, otherwise I move on. Then I create an unordered map. And inside the map, what I do is I iterate the first vector and I use each element as the key and its index as the value. That's the way I'm storing it. So for each element, I'm storing its index. So for 1, I'm going to be storing 0. For 2, I'm going to be storing 1. For 3, I'm going to be storing 2. Right? And then I create a stack called indices. You can create a queue as well in this case. That would not matter, or just use a vector simply. As I said, doesn't matter one bit. So I created a stack, and what I did is I iterated the other array. And inside the other array, what I'm checking is if for any element, if the index of that element is different than the index of that element in the other array. So for example, in this case, the first element is going to be 2 and its index is 0. But inside the first array, using the map, we can see that the index of this element is actually 1 in that case. So since 1 is not equal to 0, I'm going to be pushing the index of this element 2 in this other array inside the stack. So as we can see, I'm pushing it inside the stack. So this index has been pushed inside the stack, and similarly index of this one will be pushed inside the stack. This 3 would not be pushed. So then the condition after that we are going to be checking if the stack has only 2 indices in it or 0 indices in it, because if it has more than 2 indexes, then in that case we can never actually solve it using just one swap. And if we have only one element which is not in the right place, then again we can't solve it using just a single swap. So after that, if the condition is not satisfied, then I just return false, otherwise I move ahead. And what I do is I just swap both of these elements together. So I just take both the indices as first and second, I swap them both in the second vector, and then I just return if vector 1 is equal to vector 2 or not. We don't necessarily need to do this, I guess. We can just return true by this point, because we have already checked all of the conditions that are required to satisfy this, except for the condition to check if all the elements are equal or not. But I think that can easily be satisfied using this indices. But anyways, that doesn't matter. This condition can help. Actually no, because the map, for example, if that element doesn't exist in the other array, for example we have stored 1 2 3 inside the map and we check for 4, it doesn't exist anyways. So in the first case, the index is going to be equal, so it won't be pushing anything inside of it anyways. So I think I should add another condition. Yeah, if the element is not found in the map at all, then in that case we can also return false. So let me do that. If map.find vector 1 of I, is double equals to. In that case, we can just directly return false, I guess. So this should work. I've tested the solution already. It works. Now let us ask ChatGPT if the solution is correct or not according to it. Let me do that quickly. Yeah, as you can see, it says we don't actually need a map or a stack. So it is just directly comparing the vectors themselves and only using two, what do you call it, only passing in the two possible cases. As we can see, these cases right here. And yeah, so basically it is comparing all the elements of the vector one by one. If they are not equal, it is storing the index. Basically, that is all it is doing. And it is checking the size, and then according to both condition, returning true or false. And then if there are exactly two elements, it swaps them, and then it returns the vector. Simple as that. So that is the way it is telling me to do it without using map. Obviously, since we are practicing a map, I solved it using a map. So we can just move on to the next question. This question was quite stupid to be solved with a map. I don't know why it is even in here, but anyways, now we can move on to the next one. Hopefully these questions are going to be good. You can also try them out with me if you want to. I will mute myself now. Okay, guys, so we have solved problem 11th as well. In this, we had to check if two given strings are isomorphic or not. So, two strings are isomorphic if if the characters in one string can be changed to a specific other character, or if they can be mapped to another character, so that it becomes the second string. For example, in this, E can be mapped to A, as in E can be changed to A, and G can be mapped to D, as as in you can kind of say G can
Stop.
uh, be replaced by D. So you can say there is a one-to-one mapping in this, right? So if you have a one-to-one mapping between the strings, if a one-to-one mapping between the strings is possible, then it is a set of isomorphic strings. For example, as you can see in the next one, since we have foo and bar here, F can be mapped to B completely fine, O can be mapped to A completely fine, but O is getting mapped to R as well. So it's a one-to-many mapping in this case, so that would not work. So it has to be one-to-one mapping for the strings to be isomorphic. So what I did for this solution is that uh, I created this function called solution. In this, I'm passing both the strings that I'm taking as input, and I create two unordered maps, MP1 and MP2. So both of these will be keeping a track between each other for the mapping, so that we know that the mapping is a one-to-one mapping. And if it isn't a one-to-one mapping, then you know that that the set of strings given to us are not isomorphic. So first of all, we are going to check the size of these two strings. Obviously, if their size is not equal, then the mapping cannot possibly be one-to-one in this case. So you just return false. And by the way, when I say one-to-one mapping, uh, also keep a check of frequency count. So the one-to-one mapping has to be in terms of frequency as well. For example, if G is getting mapped to D, it can only get mapped to D for the whole string. So that is what I mean basically. So anyways, now what you can do is in the map you just iterate the strings. Obviously, since their size are equal, you can iterate them along each other. So for you take the current character of both the strings that we have, and then you check if in the first map we already have that character or not. If you already have that character, then we have to check if that the mapping of that character is equal to the character in the other string. If it is not equal to the character in the other string that we currently have, the character that we have currently have in the other string, then we know that that mapping is not possible, and we can just directly return false. Otherwise, if it is not present, you can just put it in the map, and you can do this for both the maps. One map maps string 1 to string 2, other map maps string 2 to string 1. And once you've iterated them completely, then you can just return true. In my opinion, this question can be solved a little bit easily using sets instead of map, because with sets what you can do is you can just directly put both the strings in sets, I guess, and then just check if the size of the sets is equal or not, because the duplicate characters will be removed. So if the characters are duplicate in the same way, so they can be mapped to each other and it can work accordingly. So that would work, and that's the way you can do it using sets easier and easily. I don't know if this solution is even completely correct or not, so let me ask ChatGPT quickly. Yee-hoo.
Yeah. 3. Bahkan itu
Okay, I mean my map solution is correct, but ChatGPT is saying that the set solution that I was thinking is incorrect. I don't know how that works because all of the test cases that it has shown me, the set solution seems to work correctly on all of these. But okay, anyways, I won't be wasting too much time on this. I will just move on to the next question, which is the 12th one. You can also try solving this along with me if you want to. I will mute myself now. Okay, so we have solved this question as well. Uh, in this, we had to find the longest substring with k unique characters. So basically, we are given a total of 2 unique characters, and we had to find the longest substring in the array that has that number of unique characters. For example, since we want 2 unique characters, you can start from the left. A. Although the size of the substring is 2, but number of unique characters is still 1. Then we get to B. Number of unique characters is 2, but so we can put the size to 3. Then we move ahead again. Size has increased and number of unique characters is 2, so you keep it there. When it increases, you can just start decreasing from the left, so that the condition is not violated for the future. So I mean, as soon as I laid my eyes on this, I could tell this was a sliding window problem. The only thing that I just still don't understand right now is how is this a map problem? In my opinion, this does not require a map at all. If anything, we could have used something like a set, and even then, we don't exactly need to use those. You can just do it without them. But okay, anyways, I was stuck for a long time on this question, figuring out the solution. I just was not able to because I just could not see a reason for using a map in this. Obviously, any kind of data structure you can use anywhere, but it is like the most pointless way of solving it, you can kind of call it. So that is exactly what it felt here. So I started searching for this question, and the only solutions that I found, none of them were using a map. Basically, they were solving it exactly the way I would have solved it. But anyway, so I just had to somehow figure out a solution using a map. I will explain it to you quickly. For the sliding window, we have 2 pointers, left and right. For the maximum length, we have a variable max length. Then we create an unordered map. We just run the while loop until right is less than the size of the string itself. Then as soon as we get in the while loop, we just increase the frequency of that character in the map by 1, or the character in the right by 1. And then if the size of the map becomes greater than k, basically there are more unique characters in the map than required, then in that case we can start popping from the left. How we do that is you can just start sliding from the left and decreasing the frequency of the leftmost character in the map, and whenever that frequency becomes equals to 0, then you can just erase it from the map and update left accordingly. Then after this, you can just check if the size is equal to k. Then we can check for the condition of the max length of the substring. So if right minus left plus 1 is greater, you just put it equal to that. After that, you can just update right by 1, and that is the way you solve it. Simple question. The question itself is simple, just unnecessary use of map made it extremely difficult in my opinion. But okay, anyways, now we should move on to the next question. You can also try it out with me if you want to. I will mute myself now. Okay, guys, so I've solved problem number 13th as well. It was a very simple problem. In this, we had to count pairs with a given particular sum. So, in the array, we just had to find pairs that add up to a sum that is being input by the user. So, for example, let me show you a test case. Yeah, so as you can see, we have an array 157 minus 1 and we have a sum 6. So we have to count the total number of pairs that can sum up to this 6. So in this case, the pairs that can sum up to a total of 6 are 1, comma 5 and 7, comma minus 1, right? So we have a total of 2 pairs. So this is a very simple problem. How I solved it is, first of all, I took input both for the vector and the sum. After that, I created a map, which is an integer comma integer map. So what this map is going to be storing is for any element, you can say, for example, if we have like a plus b equals sum, then the map is going to be storing is sum minus a. For example, if we are at b, if we are at a, it is going to be storing sum minus a, which is going to be b. So basically, if we are at a, then we need to find b, right? So if we are able to find b in the future and that b already exists in the map, then we know that we have found the sum that we are looking for, right? So, or you can also do it the other way around. Instead of that, you can just put an I and you can try finding sum minus I. I did it this way. So what I did is, first of all, I took an initial count of 0, then I iterated the vector. In the vector, first condition that I'm checking if the current element is already present in the map or not. If it is already present in the map, then the frequency of that character is what I'm going to be adding to the map, the count, to the count. And if it does not exist in the map, then that element has already appeared for us. So what we need to check if the element needed to get the sum equal to the sum given to us, if that element is present in the map or not. So for that element to be present in the map and to be present in the vector, so we are going to be putting that element in the map and increasing its frequency by 1. So if we find it anywhere in the vector, then we can just add its frequency to the count. That is the way we can solve it. Then you can just print the count. The code works completely fine. There is no issue in this. So let us move on to the next question, which is problem 14th. You can also try it out with me if you want to. I will mute myself now. Okay guys, so I have solved problem 14th as well. This was quite simple, just like the last one. In this, what we had to do is, given a stream of characters, at each place we had to print the first known repeating character in the string. So for example, let us start with A. First you are at A. The only known repeating character in the string currently is A, so you are going to be putting A. Then you get another A. Now there are two A's, so there is no character which is known repeating currently, so you are going to be printing -1. Then you get B. So B is the first known repeating character right now, so you are going to be putting B. Then we get to C. Now the first known repeating character is still B, so we are going to be printing B. Then we get C again, but since we still have a known repeating character here, the first known repeating character, which is B, we are going to be printing B. So the question is very simple. The solution is also quite simple, so I will explain it to you quickly. In this question, what we are using is, we are using a map and we are using a queue, because we had to keep a track of the first known repeating character, which is going to be on the very left. So we can use a queue in this case, and a map to keep a frequency count. So what I'm doing is, I have a result vector obviously. So what I'm doing is, I am going to be iterating the vector. Each character that is given in the string, I'm going to be pushing it to the queue, and then I'm going to be updating its frequency in map. Then I'm going to use a while loop, and I'm going to be popping from the front of the queue until I have a character which has only appeared once in the queue, or until the queue is empty, right? So we are going to be checking if the frequency of the character in the front of the queue is greater than 1, or if the queue is not empty. If the queue is not empty and the frequency of the character in the front of the queue is greater than 1, then you're going to be popping from the queue. So after that, if the queue is empty, then we can just for that place we can just say that there is no known repeating character, so you can just push in a -1. Otherwise, if there is a repeating character, meaning that if the queue is not empty, then you can just push that character in the result, that known repeating character, and then you can just print everything out. So this is a very simple question. Just since we have already practiced stacks and queues and everything, so the solution to this problem came to my mind quite quickly. So that was helpful, and I hope you tried it as well. Simple question, simple solution. Now we can move on to the next one. You can also try it out with me if you want to. I will mute myself now. Okay, guys, so I have solved the very last question as well. In this question, we had to basically print out the elements, the top k frequent element. So basically, we are given an integer k, and all the elements that have a frequency equal to and greater than this k, we had to print them out in a priority order. And I think the priority order in this case was the frequency. So basically, the more frequent a character is, you have to print it out first instead of just any random order. Or you can also do it in lexicographical order. So if you were seeing me code previously, what I was doing is I had made this priority queue and a map, and this priority queue was of a string, and in the priority queue, I was also pushing in all of the strings, right? So basically, I was updating the frequency of occurrence of a particular string in the map, and I was also pushing that string in the priority queue, right? So then after that, what I was doing is I was running a while loop until the priority queue was empty, and if the frequency of the element at the top of the priority queue or the frequency of the string at the top of the priority queue was greater than equal to k, then in that case I was printing it out. But that would have given us elements in the priority of the lexicographical order of the elements or the string, you can say. So basically, like in apple and banana, all the apples should be printed first, banana was printed first, I think, because that is the way priority queue works. So anyways, so what I decided to do in this case, since there is no literal particular way for me to create a comparator, or at least since I don't know a way to create a comparator that would have taken the map into account, that would have used the map that I was creating, what I did is I just flipped the older map that I had created. So since I couldn't have used, since initially I was ordering the elements in the lexicographical order of your elements, or you can say the strings, and the value of the map was the frequency, and if I wanted to order them according to that frequency, what I can do is I can flip the map, and inside the priority queue, instead of the string themselves, I can just push those frequencies inside the map, inside the priority queue, and then I can just, obviously, since the highest priority element, or you can say that the biggest element is going to be on top of the priority queue, you can just pop that, and if it is greater than equal to k, you can take the string from the map, the string that it has from the map, and just print it out accordingly. By the way, another mistake I've made here is I'm using an unordered map. Instead of this, I'm going to be using a multi-map, right? Because if I'm not using a multi-map, then it won't work, and you cannot use square brackets with a multi-map. You will have to use the, I think it is the at operator, or let me just check quickly. Clear empty. Okay, extract it is, I guess. Basically, doesn't seem to be here. But okay, I think you get the point that I'm saying. Let me just quickly check multi-map again. Okay, so basically in the multi-map, I will have to use the equal range operator. So what I can do is, for example, I have my map. I can do equal range of top, right? Equal range of this. Now we can take the first of this, which is going to be this, and from here we can access the second element of this, and that should be the string that we are trying to use. And then you can, if you want to remove this element from the map, which we will have to now, so you can just take mp1.erase. I think it is erase, right? Let me check for a second there. So it is erase. So what you can do for this is you can just say mp1.find. It will be finding the first occurrence of the element itself. pq.top, this is the first occurrence of the element, and it is going to be popping it. So we are adding the first occurrence of the element using equal range. We find the very first occurrence of this key in the multi-map, and then we add it to the result, which is the value of it, which you can access using second. So just a second, let me also fix this bit of code right here, because in the map you can't use in the multi-map you can't use square brackets to insert. You have to use the insert function. So anyways, this is the way you can insert. What is it showing right now? What does it mean by overload? For a second, just a second. Let me check. Oh, I have to use emplace. Yeah, forgot about this. My bad. You can use emplace to put the elements like this, and then what I can do is I can take the first occurrence of the particular key, which is the top of the queue for the most frequent element, and then its value, which is going to be the second of the pair, its value I am going to be adding to the result, which is the string itself, and then I'm going to be finding the first occurrence of it and erasing it from the map. That is the way I can do it, and then I can just pop it from the queue as well. That's the way you can do it. You can also test out this code quickly before I explain it to you once and for all. So let us see if this works or not. Hopefully it works, and if it doesn't, yeah, it works. So let me explain the code to you quickly. In this, I'm basically printing out the top k frequent elements using a priority queue. So basically from the most frequent to the least frequent among the top k most frequent elements, or basically the elements whose frequency is greater than or equal to k, right? So even those elements, I am printing them out in their frequency order. So basically in the descending order of frequency, you can say, decreasing. So what I do for this is, of course, after taking the input, first of all I create a map. In that map, there is a map of string, integer. This is the frequency map. So I'm going to be storing the frequency of each string inside of this map, as I'm doing right here. And then after this, what I'm going to do is I'm going to reverse this map, right? Now since I want to reverse this map, duplicate values are allowed in an unordered map, right? Since duplicate values are allowed in an unordered map, we have to use a map that allows duplicate value, which in this case is going to be multi-map, right? So in the multi-map, we are going to be storing frequency, string. So basically we are reversing it. The key becomes the value and the value becomes the key, right? So what we are doing in this is we are iterating the map, and if the value or if the frequency count is greater than or equal to k, then we are going to be putting the frequency count, element inside the multi-map, and we will be pushing this frequency in the priority queue as well. And then I create a vector called result, and I will be running a while loop until the priority queue is empty. So basically now the priority queue only has elements which are already greater than equal to k, right? But since we are using a priority queue, all those elements are already going to be in sorted order, in reverse sorted order. So the highest element is going to be at the top because it uses a max heap. So you just take that element at the top. You are going to be finding the first occurrence of that element or the first occurrence of that frequency in the multi-map, right? So the first occurrence of that frequency in the multi-map using equal range and first. So basically multi-map dot equal range, the key which is basically the top of the priority queue, and the first of it basically going to be the first occurrence of that key. So the first occurrence of that key, now we are going to be taking its value, which is going to be the element itself or the string itself. Now we are pushing it in the result. Then we erase the first occurrence of that key from the multi-map using dot find function and dot erase, and then we can also pop it from the queue, the priority queue. So that's the way you can solve this question. I know it might have confused you a little bit. I'm just saying that if in any case ever you have to order or you have to use a frequency count of the elements or basically the value of the map for any kind of ordering or checking, but since it is not directly possible, what you can do is you can flip it, and you can flip it using a multi-map. A multi-map because for the value duplicates are allowed instead of the key. So since duplicates are allowed, you can have duplicate values. So multi-map could be useful in that case. So you can solve it like that. I think my solution works completely fine. Let me ask ChatGPT as well once and for all, and then we will be finally done with our problem set of maps. Right. This is my solution for problem 15. Is there a more? Let's just see if it is correct or not. Wait a second. It is. I don't want suggestions. First, tell me if it is correct or not. Although I don't necessarily need to ask it if it is correct or not, but anyways, wrong or incomplete results. Okay, may not preserve insertion. Okay, it might not preserve insertion order, but it is not exactly asking insertion order anyways, right? Then we can just do the lexicographical ordering or anything you want. You can order it in the insertion order. So to make it, if you want to do according to the insertion order, then what you can do is you can iterate the original vector again, and then start pushing it in, checking from the map and pushing it in the result. In that case, you won't need priority queue at all. So with this, we have completed our problem set of maps. There were some good problems and some just completely unnecessary problems, basically problems that are not to be solved with map. So most of them were good. So this was the problem set of maps. I hope you tried them as well, and I hope my explanation of the solutions was good enough. If you think, if you have any kind of doubt, or if you think I made a mistake anywhere, you can just comment down below and let me know. So this is going to wait for this video. Next, I'm going to be trying to solve problems of something else and upskill from there. So see you guys next time. Have a good day. Bye.
So please whatever. Please I want to reach 1 million likes. So please Okay, thank you.